setup I used for my design project. We have 3 HC109 ICs representing the 5 different flip-flops I used, with the top HC109 being the tracker flip-flop, then the HC04 being the 6-input invert gate, and then we have the HC08 being the 4-input AND gate, and the HC32 being the 4-input OR gate. And then at the top also the transistor that was used to create the 5-volt clock pulse. After that, I began to power up all of the ICs as well as ground them. So the top right pin for most of these ICs was the VCC pin, and they all received a 5-volt input. I had to bring over a wire from the rail on the left side of the breadboard to the other side of the breadboard to be able to power these ICs without having to cross over so many wires. This picture demonstrates the 2N transistor that was used and how the collector pin has the orange wire coming out of it that will denote the 5-volt clock pulse that I will be using. This clock pulse gets sent to an inverter right away, and the output of that inverter is what is used for my clock pulse. And then this photo demonstrates the clock pulse going to all of the flip-flops, one of them being at the top and then the other 4 near the bottom. After that, I began to wire the inputs of the JK flip-flops that were independent of any logic gate outputs. So this was like wiring inputs to ground or to high or straight from one output to another input, which can be seen here by K4 bar being Q1 and K0 bar being Q4. With the inputs to all the JKs being yellow wires, I decided to use blue wires to denote all of the wires that were going to and from logic gates. So here we see the wiring of the first 3 logic gates, the AND gate 1, AND gate 2, and OR gate 1, with 2 of the outputs of these going to inputs of JK flip-flops. However, I did not wire them until all of the logic gates were wired properly. I then proceeded to wire the 2nd and 3rd OR gate and the 3rd AND gate, as can be seen by the additional blue wires that were added. At this point, it starts getting a little bit messy, so it is a little bit hard to see, but I hope that the labels make it clear what is happening. And then lastly, I wired the 4th AND gate and the 4th OR gate. While I was doing all of this, there were also wires going to and from inverters, which were necessary for the AND and OR gate inputs, and those can be seen by additional blue wires being added to the top of the breadboard. And then this photo shows that after I finally wired all of the logic gates properly, I took the yellow wires from the outputs of those logic gates into the inputs of the JK flip-flops. The next few photos will be just a little showing of side views of the overall design at this point, with the inputs of the JKs filled and all the logic gates properly wired. The last piece of wiring that had to be done is seen by these additional white wires. These were used to be the inputs to the clear and preset inputs of certain JK flip-flops that were needed to set the initial state to 4. So these were added so that I could manipulate them before starting the clock pulse, so that I could set the initial state to being the necessary 4 value. After this, I checked my function generator to make sure I had a 2-volt peak-to-peak clock pulse coming out of it. Then I began to measure the actual clock pulse that will be used for the logic gates, the JK flip-flops, and then the following picture denotes the oscilloscope reading of both, with channel 1 being the clock pulse that was going to be used, and as you can see, it is a 5-volt peak-to-peak clock pulse. And then lastly, I used these LEDs before I wired my 7-segment display to determine the functionality and make sure that it was actually working and the JKs were sequencing through the correct logic.